All right, so up to now, we've been designating different quantities as either scalars or vectors. Scalar quantities are those that are recorded as magnitude only, such as the total distance that an object travels or its speed. Other quantities that we will discuss later on include temperature, time, and mass. Vector quantities are those that are recorded with a magnitude as well as a direction. Vectors are represented in a coordinate system using arrows. The arrow represents the quantity being described. The head, or the pointing part of the arrow, points in the direction of the event. Say these arrows represent velocity. The first object would be moving in a northeasterly direction, while the second object would be moving nearly due east. The magnitude of the event is represented by the length of the arrow. Here, the middle arrow would be moving fairly slowly, while the next one would be moving pretty quickly. Since vectors are representing actual measured quantities, it's important to draw them correctly. The first rule in drawing vectors is to draw them to scale. This means getting a ruler out and drawing a straight measured line. In this example, a scale is 1 centimeter equals 10 meters. Since the displacement indicated here is 50 meters, the arrow would be drawn 5 centimeters long on your paper. The scale also includes the direction. Use a protractor and accurately measure the angle at which the object is moving. The second rule, which you would think might be obvious, since vectors are represented by arrows, you'd be mistaken. Make sure that the vector is actually drawn as an arrow. Make a definite head that points in the same direction as the vector. Draw a straight line behind it that represents the magnitude of that vector. It is important also to label the magnitude and direction of the vector, even if you've provided a scale and have drawn the most beautiful vector ever seen. Someone might come along and not have a ruler or protractor available. Or your vector might be viewed from a computer screen, like this one, and you won't be able to measure it very well. Or your vector might be viewed on a computer screen, like this one, and the scale gets all out of whack. Labeling the magnitude and direction allows someone to see at a glance what the vector represents. Now a bit more about direction. There are several different ways to indicate the direction of a vector. One is by using the positive or negative direction. This only works when the event is occurring along a straight axis. The cardinal directions, north, south, east, and west, are convenient to use. These can also be used in conjunction with angles. The example shown here would be described as 30 degrees east of north, or 60 degrees north of east. You could also just say 60 degrees as long as you understand that an angle without a direction has been measured from the axis drawn along the east. Note that left and right are not good indicators of direction because they are dependent on observer's frame of reference. If I am facing you and say our little buggy car is moving to the right, you would at the same time say it was moving to the left.